Hey everyone, and welcome. So, today we're going to take just about 5 minutes to deconstruct one of the most powerful and maybe most misunderstood technologies shaping our world, artificial intelligence. We're going to break down what it is, how it actually works, and some of the huge questions it's forcing us to ask about our future. Let's dive right in.
It all really boils down to this one single question. And no, this isn't just a line from a sci-fi movie. This is the big one. It's the philosophical challenge that has been the engine behind the entire field of AI from the very beginning. Can we actually build something that isn't alive, but can mirror our own intelligence?
To get our bearings, let's go straight to the source. This is a quote from John McCarthy, the guy who literally coined the term artificial intelligence way back in 1956. And I love his definition because it's so simple and so direct. He's saying this isn't just about big ideas. It's about the hard work, the science, and the engineering of actually building machines that can think.
Okay, so before we get into all the crazy cool things that AI can do, we've got to get a really clear picture of what it is. This is the groundwork for everything else. So, at its absolute core, AI is this mission to build systems that can copy human thought. You do that by studying how our own brains work, how we learn, how we make decisions, how we solve problems, and then you try to use that as a kind of blueprint for software and robots. The key phrase here, the whole goal, is to think intelligently. And this whole mission really splits into two major ambitions. The first one is super practical, creating what are called expert systems. You can think of these as highly specialized digital tools that can learn a ton about one specific thing and then advise us on it. But the second goal, the second goal is so much bigger. It's about actually putting human-like intelligence into a machine, creating something that doesn't just know one thing, but can understand, learn, and behave across the board, just like us.
Which, of course, leads to another massive question. If the whole point is to build an intelligent machine, we kind of have to agree on what intelligence even is, right? What does it actually mean to be intelligent? Well, when computer scientists talk about intelligence, they usually break it down into these 5 core abilities. You've got to be able to reason, to make judgments. You absolutely have to learn from experience. You need to solve problems, to perceive the world around you. And of course, you have to understand and use language. Any AI you can think of is basically an attempt to build and combine these different pieces.
Now, this is where things get really fascinating because it highlights a huge difference in how we operate. We humans are amazing pattern matchers. We can see a couple of squiggly lines and instantly recognize a friend's face. Machines, on the other hand, live and die by rules and data. They need things to be precise, complete. And that single difference is why an AI can beat the world's best chess player, but might totally fail to recognize a cat if the picture is a little blurry. It's what makes AI both incredibly powerful and sometimes surprisingly fragile.
Okay, so that's the theory. Now let's talk about where this stuff actually shows up in the real world, in the tools and services you and I use every single day, a lot of times without even realizing it. Remember that first goal of AI we talked about, building expert systems? Well, here they are. Think of an expert system as like a digital consultant that has superhuman knowledge, but only in one very specific area. It's built to tackle really complex problems at a level that equals or even beats a top human expert. And these things are everywhere, working behind the scenes. The system that helps your doctor diagnose a rare disease, that's an expert system. The software that tracks thousands of flights in real time to make sure they don't collide, yep, that too. Or the algorithm that instantly flags a weird transaction on your credit card, all expert systems doing their thing. Now for another huge area. Natural language processing, or NLP for short. This is the magic that lets us talk to our machines. It's the science of teaching a computer how to understand human language, with all of its weird rules, its slang, and its ambiguities. And this slide just perfectly shows how incredibly hard that is. To understand one simple sentence, a machine has to go through this whole 5-step process. First, it breaks our speech down into individual words. Then, it checks the grammar to see how those words fit together. After that, it has to figure out the dictionary meaning. Then, it looks at the sentences that came before to get the context. And finally, the hardest part of all, it tries to figure out our intent, what we actually meant versus the literal words we said. Next up, we've got artificial neural networks. And this is so cool because it's where AI developers took their inspiration straight from Mother Nature. They're literally trying to build digital brains using these interconnected nodes that act like our own neurons, to process information, learn from it, and make new connections. And because they're built to mimic the brain, it turns out neural networks are just phenomenal at pattern recognition. This is why they're the engine behind everything from your phone unlocking when it sees your face to the autopilot system in a jumbo jet. They can be trained to spot cancer cells, to guide a self-driving car, or even to try and predict the stock market by finding tiny patterns no human could ever hope to see.
So it's pretty obvious that AI isn't just science fiction anymore. It's a real, powerful tool that we're already using every day. But as it gets more and more advanced, it brings up some incredibly important questions about the kind of future we're actually building. And with all this power comes some really critical challenges we have to figure out. There are massive concerns about privacy, especially as AI gets better and better at listening to and understanding our private conversations. There are big questions about human dignity as we think about replacing people in jobs that need moral judgment. And then there's the big one, the long-term safety question. What happens if an AI becomes so smart that it can start improving itself without any human help?
And that really leaves us with this final, crucial thought. An AI isn't born with values or biases or ideas of its own. It learns everything from the mountains of data we feed it. Every book we've written, every video we've made, every conversation we've posted online becomes its textbook. So the most important question isn't just what can AI do? It's what do we, its teachers, want it to become?